Example 1. 30-meter long extension cord is made from 19-gauge copper wire. The wires carry currents of equal magnitudes in opposite direction. What is the resistance of each wire at 20 degrees centigrade, and the diameter of the 19-gauge wire is 0.912 millimeters? B. If the copper wire is to be replaced by an aluminum wire of the same length, what is the minimum diameter so that the new wire has a resistance no bigger than the old one? Okay, in this question it says a 30-meter long extension wire, so L is given by 30 meters, is made up of two 19-gauge wires that carry equal I's and in opposite direction. Okay, so what it's asking me is what is its resistance at 20 degrees Celsius when it has a diameter of 0.912 millimeters. Now how do I find this? I'm given formula R equals rho L over A, right? So I know L, which is 30. I don't know A, but I know that if it is a wire, it looks like this. And this cross-sectional area will be pi r squared. So that solves one of my problems. But what about rho? Where do I find rho? Well, actually, in your book, table 18.1 gives you lots of resistivities for lots of values. So look it up. Rho is 1.67 times 10 to the minus 8 ohm meter. So we have that value as well. So now we have rho, we have L, we have R because we have diameter, and diameter is equals to 2R. So this implies R will be diameter over 2. Once you have all of those numbers, plug them in, calculate for R. I calculate R to be 0.767 ohms. Okay? Now, part B. It asks me that copper wire is now wanting to be replaced by aluminum wire. But it says that the new wire should have resistance no greater than the old wire. So I want resistance for aluminum to be not more than the copper one. Okay? What I need to do now is I will plug in values. Rho aluminum, length aluminum divided by pi r aluminum squared, right? Equals, or is less than or equals to, rho for copper, L for copper, pi and r for copper squared, right? Okay, this means if theirs will be the same, these all go away, right? And I know also from table 1 that rho for aluminum is 2.65 times 10 to the minus 8 rho meters. So what do I get? Rho of aluminum divided by rho of copper equals R for aluminum squared over R for copper squared, right? R for copper squared is given here. So that's easy. I have rho for L, rho for copper, and I can calculate what R should be. So this implies that my R, or in fact D, actually I could just find D for it, right? Because that's what I'm looking for. So I have D, I can figure out, I'll leave that up to you. You can figure out what D of aluminum should be.